unit vectors. Okay, these are pretty important, especially when you start dealing with world applications. If you know you want something a certain direction and a specific magnitude, unit vectors come in really handy. So let's just quickly review, not really review, but look at a few basic vectors. So let's look at vector u, and vector u is going to be in component form at 0, 4. Okay, so 0, 4 is going to be our first vector. Okay, if you notice, could we find the magnitude of vector u? Well, if you remember, magnitude is length, and if we look at it, if it's a horizontal or vertical vector, the length is pretty easy to identify. It's a length of 1, 2, 3, 4. So this one has a magnitude of 4. If we look at vector v, and vector v is going to be the point 0, negative 6, 0, negative 5, because apparently I can't draw. 1, 2, 3, 4, 5, because 6 kind of went off. Okay, so here's my vector v, and I asked what the magnitude of vector v is. You guys would say 5, because that has a distance of 1, 2, 3, 4, 5. Vertical ones are very nice. So we have the direction in our component form. We also can see our magnitude. Direction for my u vector is east, technically, if we were looking at a compass, and for v is south. Direction and magnitude. Okay. What if I want to change these to unit vectors? Well, unit vectors have two criteria. The first criteria is that it has a magnitude of 1. Wow, struggling. So it has a magnitude of 1. That is the first criteria. Second one, it's going to be same direction as a given vector, or it's going to have a specific direction. The ones you guys are going to be doing, working on right now is they're going to give you a vector, and it's going to ask you to find the unit vector. Okay, so thinking about u, what would the unit vector for vector u be? Well, hopefully you guys said, I don't know why I turned that, that's silly of me. Hopefully you guys said, well, easy peasy, that would be 0, 1. Kind of makes sense. So same direction, magnitude of 1. What would v be? Well, same direction, distance of 1, length of 1. That would be negative 1, 0. So vertical and horizontal ones are really easy to deal with. But let's think about what we mathematically did to get those. My original one was 0, 4, and my unit was 0, 1. What did we do to our magnitude here? We divided it by 4, right? So we really took our whole vector and divided it by its magnitude to get 0, 1. If you look at vector v, 0, negative 5, and we took that magnitude and we divided the vector by the magnitude, we would get negative 1, 0. Wow, nobody stopped me because nobody's here. This is negative 5, 0. FYI, this is not 0, negative 5. Yep. So, but now it still works. Magnitude didn't change. I just apparently need to review graphing and vectors, and wow, good stuff. Okay, so let's deal with one a little bit more complicated. I know after that last blunder you're like, oh no, more complicated, this is not a good idea. We can do it. Okay, let's say we have this vector right here. Okay, I'm going to call it vector n. U and V are the most commonly used. I'm going to use n because I've already used U and V, and I'm actually going to put it over here. Okay, that's a beautiful n. This has a unit component form, so we're going back 1, 2, 3, 4, 5, negative 5, and 1, 2, 3, 4, 5. Nice. Negative 5, negative 5. Almost nice, almost bad. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You guys know if I make mistakes, go with the general what I'm trying to say, not the lack of writing it properly. Okay, magnitude. Magnitude of n is what we need to determine. So basically, it's a triangle, negative 5, negative 5. It's finding the hypotenuse, so square root of negative 5 squared plus negative 5 squared, square root of 25 plus 25, square root of 50. Well, that's 5 times 10, 5 times 2. So our magnitude is 5 square root 2. So we need a magnitude of 1. We need a little unit vector there. Just like with our horizontal and vertical, we are going to take our vector and divide it by the magnitude. So if we think about it, we're taking the vector dividing by the magnitude, or 1 divided by the 1 over the magnitude. So instead of dividing by the magnitude, I could times by the reciprocal of the magnitude times my vector, negative 5, negative 5. So I have 1 over 5 square root 2, that's a 2, times negative 5, negative 5. So my unit vector is negative 5 over 5 square root 2, negative 5 over 5 square root 2. Simplify that a bit. That'd be negative 1 over square root 2, negative 1 over square root 2. Rationalize negative square root 2 over 2, negative square root 2 over 2. So my unit vector for n is negative square root 2 over 2, negative square root 2 over 2. And if I wanted to, I can graph that and verify that's in the same direction. A little tricky to graph, so I'm going to say, oh yeah, right on. And what I drew, guys, this is not really the unit vector. I just drew like a little one in that direction. Okay, so don't go, well, what doesn't match that? Because it's not supposed to. If we wanted to, we could check this. If I did the magnitude, negative square root 2 over 2 squared plus negative 2 square root 2 over 2 squared, we get the square root of 2 over 4 plus 2 over 4. That's the square root of 4 over 4, which is 2 over 2, which is a magnitude of 1. Happy day. Unit vector. Okay. Hopefully you guys are okay with these. They're not too bad once you get kind of the concept of what you're doing. I don't think looking at your assignment you have anything tricky. Nope, you shouldn't. They do give you a few that has a given magnitude and a direction. It's actually probably a little bit simpler because you don't have to find the magnitude yourself. Yeah. And with that one, those ones are like the 57, 59, 61, and all those. Just note that they are already in component form. Okay, guys, have a great day, and yep, that's it. Bye.